Assalamualaikum. My name is Sabreen Zara, registration number 21TE103. Today I am going to perform the lab number 2 of digital signal processing, and the main objective of this lab is the signal representation. So first of all, in task number 1, we have entering the starting points and limits. So in this example, we have a step signal, that is x is equals to n minus 0 greater than equals to 0, in which means that if we can shift the signals, it will give us a positive values. So in the output graph, we can see that it will give a positive values from n equals to minus 1 to 3. In next task, we have another step signal, that is n minus n not equals to 0, and in the output figure you can see that it will give us a step signal only at n is equals to 1, and otherwise it will be equals to 0. In task number 3, we have a signal which having a limit from minus 3 to plus 3. And the signal is x is equals to 3 into 5 raised to power n, and after run the signal, we can check that we can put a different values of n in our signals, and it will give us a different amplitudes. Next is the part B of the same task, that having a limit from minus 10 to 11, we have and function is 3 cos of 3 pi into n plus 5. So in the output figure, these are the different maximum and minimum peak values of our given functions. In next task, we have our unit impulse function. The unit impulse function give us a value at only n is equals to 0. So in the output, it is clear that for other values of n it will be 0, and for value of n equals to 0 it will give us a signal. Next is the unit step function for the same example. This example shows that function will give a output at n is equals to 0 and greater than n equals to 0. So we can run this function. It is clearly say that in graph we will output for only those values which is greater than 0, otherwise it will be 0. Next we have task number 7. In task number 7, we have a flip signal. So firstly we define our flip signal, and it has two values of n. One is for original and second is for the flip signals. So we can run this function. We can observe that we can get a two subplot. First subplot is for the original signal and the second subplot is for the flipped signal. In task number 8, is about index scaling of the given signal. In this example, we can define our signal and multiply our signal factor by 2. So this will also give us a two subplots. Let's see. These are the two subplots. First is for the original signal and second is the scaled indexed version of the original signal. In task number 9, we are talking about the shifting of the signal. We can shift our signal toward the left as well as towards the right. So if we are shifting our signal towards the right, we means we are delaying our signals, and if we shift our signal towards the left, it is the advancement of the signal. So we can shift our signal towards the right. In this output figure, you can see that how we can shift our signals towards the right value. In next task, we have to stimulate the zero order hold. In zero order hold, we are actually converting our analog signal to digital form. In this example, we can initialize our signal and then display our signal. So let's run the signal. The output will show the original signal, and this is the zero order hold of the given signal. So in the last task is about the first order hold. In first order hold, we use line of equation, means we use the slope form. So we define our first signal of a hold function using line of equation, that is y is equals to mx plus c. We can get our first order hold of the given signal. In the output graph, you can see that this is the first order hold of the original signal. So thank you and Allah Hafiz.